All right, ladies and gentlemen, we are going to crunch some numbers today. So we're going to take a look at that spreadsheet with the shared data. So I'll have you open that up. The first thing I want you to do is go to File and make a copy and save your own so that we're not messing with the original information and our record of the information for the class. So you do that. I'm going to do something a little bit different. Okay, so I'm going to duplicate it. Then I'm going to go through the information ever so quickly, and I'm going to do the following. So I'm going to delete a couple pieces of information. So I'm going to delete these because, well, Gina and Marta don't exist, and Martina and Drusa said they were going to redo theirs. So we're going to delete that. And as we scroll, let's see. I'm actually make these columns a little bit closer so that we get the more condensed information and we can look at it a bit easier. Okay. I'm going to delete this one as well just because the information is not complete and I think they had new information that they haven't shared yet. So we're going to delete that one for now, and if we get the rest of their information we can just include it in the average on this spreadsheet. So then we're going to make another change. So first thing I'm going to do is I'm going to highlight the numbers, and some people said that they calculated seconds to like a small fraction of a second, but I feel like that would be really challenging to do. So just to simplify it and to be consistent, I'm going to go to Format and Numbers, and I'm just going to hit this button to give us just whole numbers, so just whole number values, and it's all in seconds. All right, the next thing then is to make a super huge number. So we're going to put that in there.
1E99.
So we're going to put 1E99. Okay, and then we're going to move that all the way across. So we're just going to make sure we're putting in a huge number there. Because it's like infinity. So it's never going to change. Right, perfect. Then the next thing we're going to do is take the average, and we're just going to do this by using the function bar. So we're going to go to the function. Okay, so not doing it in the box, but going up to the function, we have to hit the equal sign. So hit equals, and then you can just do average. And you can do this on Excel as well, and it might have one that says the mean, so that's the same, average or mean. And then we're selecting our area, so the numbers we wanted to use for a calculation, and we're going to close the parentheses and we're going to put that in there. Then real quickly, if we can copy and paste the formula all the way down, just double checking and making sure that our area is correct. But we can also go to the very corner, and once we see this little plus sign, we can click it and they'll drag the formula all the way down. So still, if you double check it, your range should be consistent. Okay, so we're taking the average for the first test tube, the second test tube, third test tube, etc. So we can check the range and make sure we got all the numbers that we intended to get in there for the average. So perfect. The next thing we're going to do, I'm going to delete this for now. The next thing we're going to do is we're going to calculate the standard deviation. So that's telling us, like, it's giving us information about how close our numbers fall to the mean or the average to give us an idea of whether or not our information was consistent or not. And that means we're going to calculate, sorry, I clicked over the other sheet accidentally, calculate the standard deviation. We're going to click in the top box first. Really all the values are the same, so they shouldn't be varying around the mean at all. But we're going to click the equal sign. Remember, anytime we're entering a function, we have to click the equal sign. And then we're going to go with STDEV, so that's just standard deviation. So we'll click that, and then it has our parentheses there. And we have to select our area. So we're going not for the average, but for the other values. Okay, so do not include the average. And then we click. Okay, so perfect. So it should be 0. There should be no variance around the mean because all the values were exactly the same. So no change. This, remember, is all theoretical. Like I manipulated this because we said there should be no change. That's the point of having the control. So this is all theoretical. So we're making these changes just to show what we would expect. Then again, in the corner, I can click down or just double click, and then we see that the formula is dragged down to the bottom box. And we can check our areas again just to make sure we included the numbers we intended to include. So if we look at this, there's a big difference. So the first one says 252. So that means that most of our numbers fall within 252 seconds below or above the mean. So that's actually a really big range. As we go down, 238 is a pretty big range. Then they're getting a little bit smaller with 62 and 93. So those ones were more consistent. So we're just trying to get a look at those numbers and figure out how we did overall. Again, I think this is way too many decimal places, so I'm just going to go to the number. And for this calculation, I'm going to click on this number, and it allows me 2 decimal places. So that's enough. I don't need a million decimal places. This is good. Perfect. So now we have our information. We are going to do some graphing first. Okay, so graphing of our information for our team and the class average. Then for the standard deviation, I will have you include the standard deviation in your report. And it would be a good thing to watch the video I post and explain what the standard deviation means, show the formula, and show an example calculation. So not for all of them, but maybe just choose one. Don't choose the one that's 0, because that one's very obvious. Other than that, to start, I'm going to do this a little bit differently. So I'm actually just going to click off. I'm going to go to Data. And I'm going to go to Insert, Chart. And I want to insert a scatter plot. So let me go down to the bottom. So I'm going to hit Scatter. And then for my data range, let me move it out of the way. For my data range, I'm going to open this box because we're going to have a few different ranges. So the first range that everyone should be putting in is the quantity of yeast. Okay, so that should be in there. Then we should be adding another range. So I'll add another one. I just got to choose someone's data, so I'm going to choose this group. Okay, then you need to use your data, obviously. And then we're adding our other last range, and for everyone, that should be the average. So I'm clicking that, and I click OK. All right, so what we should see now is some decisions have been made about the values and the scale of the X and Y axes. So we need to make a few changes because we can't see a darn thing. One, we need to, let's see, go to customize, I think. We're going to first go to our vertical axis because that's what's really throwing it off because we chose, let me see, sorry. We chose the infinity type number, so we chose a giant number. We actually don't want to go all the way up to that huge number. So I'm going to go from 0 to, I think 1100 would be fine. All right, perfect. And we've got our values there. I see something interesting. Let me see. Okay, I'm going to click this. Vertical axis. Okay, perfect. Series. Axis for the chart series legend. Horizontal axis. Data. Okay. So I see something which is this. I really want to be within my x-axis. So I'm going to remove it right now. And then for my x-axis here. For my x-axis, I really want my experimental variable, my independent variable, which would be the quantity of yeast. So I'm going to make sure that that is there. I'm curious as to why it says the copy on the side, but that's okay. All right, and then we'll see how that altered some of my data. Okay, 0, 1, 2, 3, okay. Okay, so then I want to go back and just take a look at the settings that are going to make this look the best. At this side, we want to make sure that we're going from 0 to whatever whatever's close to our max. Within reason, so we're not going all the way to infinity, so I chose 1100. You have to have this clicked, so it says allow bounds to hide data, so that infinity point isn't on there. And then for the number format, instead of from data, because if I have from data, then I have this. I don't want that. I want it to be custom, so that I'm just getting regular numbers along the side. So perfect. Whoops, no. See, that's what happens when you click off. So now I've got this information. Okay, perfect, perfect. Obviously, we're missing a lot of stuff. So for the title, you have to come up with a specific title. Then let's see, you can switch for each of them. You have to write a label and units. Okay, so perfect. Label units. And then for my vertical, the same. So you need to label it and write the units. Okay. Have that. Okay, you need to make them specific to the information that you have. But we're going to be looking at the data sets, and we're going to be going to series, and we're going to come up with some trend lines. So I'll have you click the trend line. For the trend line, we want to show the R-squared just to see how well the line fits the data. There's a few things you need to know. One is that it can't be linear because it cannot cross the y. Okay, it can't cross, right? So it can't cross the y it can't intercept the y axis at all because it just wouldn't make sense, because we know that at zero the oxygen level really should not be depleting. It should take an infinite amount of time for the methylene blue to change. Done. So it can't be linear, so instead we're going to click through and we're going to look for something that would fit fairly well. So we're trying to think, okay, linear, it's not going to work. Exponential, looking a bit crazy. All right. Polynomial, okay. Don't even see the line on there. Logarithmic, okay. So logarithmic is probably going to be our best fit, okay? So we're going to see like a quick change over a certain period of time and then a lot slower change over the end. So I'm going to leave this and then I'm going to click on my blue. So now I'm on the blue series and I'm doing the same thing. So our logarithmic was a good fit before, so I'm going to try that. And then let me see, label none. I don't want no label. I want to use the equation. So if it doesn't show up, click use the equation and then click show the R-squared. In fact, actually for the red, I think I have the trend line series with R-squared, but I don't have the actual equation. So where it says label for the red, I'm going to add the equation as well. So this is the R-squared value is showing me how well that line fits the data. So these aren't bad. So, 0.86 and 0.955 is actually pretty good. So that's fine. We've got our information there. We have it all labeled. This is what we're looking for a graph. And really remember, the big thing we have to consider is like it can't in any way ever cross the y-axis, because that wouldn't make sense for our data. So we have to be thinking about those types of things as we're looking at the trend lines. So again, we're going to see like a rapid change, and then it's going to level off when we have this logarithmic scale. And we'll need to talk about that within our analysis of this graph as well, and why we would choose that. That's a good part of the analysis portion. So I'm going to have you make your own graph. It should look fairly similar to this. Of course, it should have some specific title and labels as well. All right, best of luck. Let me know if you have questions.